Chapter 9.5 Notes, Solving Trigonometric Equations. This is page 4. Notice now we're going into something a little different. We want trigonometric equations that are in quadratic form, okay? And here's the thing, as we look at this, when we've got all the words in there, the sign, a lot of people don't see this as looking like a quadratic. So what I'm going to do is rewrite this, and this is totally up to you. You don't have to. We're going to rewrite with x in place of the sine theta. And that's just for the time being, so it looks a way that we're a little more comfortable with. And then I'm going to rewrite this as 2x squared minus 5x plus 3 equals 0. This is a quadratic. If I can factor it, it's going to make my life a little easier. So the only way to get 2x squared is 2x and x. The only way to get 3 is 3 and 1. I know that I need to be able to multiply them and get a positive 3, which means they're either both positive or both negative. We're going to add our pieces together to get a negative 5x, which means both of these have to be negative. We're going to factor it this way: 2x minus 3 and x minus 1. That gives me a negative 2x minus 3x for that middle term. I get minus 5x. Okay, so both of these multiplied together equals 0, which means that either 2x minus 3 equals 0 or x minus 1 equals 0. When I solve here, I get x equals positive 3/2, or x equals 1. Okay, and so now I'm going to go ahead and replace my x with my sine theta. So this says that sine theta equals 3/2. Or the sine of theta equals 1. And since I know that my outputs for sine and cosine have to be sandwiched between -1 and 1, I know that this is not even possible. There is no angle that is going to have a sine bigger than 1. So I'm not worried about that value. To the right here, sine theta equals 1. The only place that happens is at x equals pi over 2. Okay, sorry, theta equals pi over 2. And then I'm going to go back and reread my problem statement. I am looking for values that lie between 0 and 2 pi. Pi over 2 lies in that interval, and so we are done. And that's it for example 10. Example 11, I got sine squared theta equals 2 cosine theta plus 2. Again, I'm looking for solutions on the unit circle. The one thing that bothers me here, though, is that I've got a sine and a cosine. It's not going to be incredibly easy for me to solve with both of those. So I'm going to go back to our Pythagorean theorem, Pythagorean identity. And I'm going to use the fact that I know that sine squared theta plus cosine squared theta equals 1, which means I can solve for sine squared theta, and I can always replace that with 1 minus cosine squared theta. So that's what I'm going to do here. I'm going to write this as 1 minus cosine squared theta equals 2 cosine theta plus 2. It's looking like a quadratic. I've got cosine squared and cosine, so I'm going to go ahead and move everything to the right-hand side. That makes this positive cosine squared theta plus 2 cosine theta. I've got the plus 2 here, minus 1 from the other side, which gives me plus 1. Again, you can rewrite this and replace the cosine theta with x if you would like, or factor cosine theta plus 1 times cosine theta plus 1. So my 0 equals cosine theta plus 1 quantity squared. That means cosine theta plus 1 has to equal 0. Cosine theta has to equal negative 1. And that happens where theta is pi. 180 degrees, halfway around the circle. Keep in mind we could have gone the negative direction, negative pi, but negative pi does not fall within our interval up here. So we want to make sure that any solution that we find lies in this 0 to 2 pi interval. And that's it for that one. Example 12, we want all possible solutions for 2 sine squared theta minus 3 sine theta plus 1 equals 0. Okay, and so I'm not crazy about the numbers in front of the sine. I'm going to rewrite this with x in place of sine theta. I get 2x squared minus 3x plus 1 equals 0. Gives me a 2x and an x. 1 and 1. They've got to multiply to give me a positive 1, so they're either both positive or both negative. Add to give me a negative 3x, so I know that both of these have to be negative. So I've got 2x minus 1 equals 0. That means that x would have to equal positive 1/2. Replace that with our sine theta equals positive 1/2. And theta, sine of theta is positive 1/2 in the first and second quadrant. That's going to be where theta equals pi over 6 and 5 pi over 6. That's once around the unit circle. Let's take a look at this other one here. I've got x minus 1 equals 0. X equals 1. Sine of theta equals 1, where theta is pi over 2. Now I'm going to go back up to my problem statement, and notice here that it says find all possible solutions. So that means we're not just going around that unit circle once. We want every coterminal angle. So I got theta equals pi over 6 plus anything that's coterminal to that, plus 2k pi. Theta equals 5 pi over 6 plus 2k pi. Or theta equals pi over 2 plus 2k pi. And in all of these instances, k is an integer, and we've got to be specific about that. And so when we're asked for all possible solutions, keep in mind that anytime we go around the unit circle again, we are going to have another coterminal angle that is going to solve this equation.